Welcome back. Hopefully test number 3 went swimmingly. Our last few classes of the semester are all about conic sections. Today we introduce the conic sections with purely geometrical definitions, and then over the next 3 classes we will talk about the algebraic versions of those same shapes. Coming up, project number 9 will be assigned in a few classes. Required Form 3 is due in a few classes. We have one more quiz, and then the final exam itself. Go ahead and take a look at your specific calendar for the date on which you should be taking the final exam. Let's begin here. Today we consider several different curves that are called conic sections: circles, ellipses, parabolas, and hyperbolas. You've seen equations for some of these kinds of curves. We will give purely geometric definitions for these curves. Okay, so the conic sections are comprised of exactly these 4 shapes. I expect you're quite familiar with the first 3 and maybe less so with the last one. We will talk in a future class about why these 4 things are grouped together and why we give them the name conic sections. Number 2, what is the definition of a circle? So, circle is the set of all points that are a given distance, and then I'm going to leave a blank space here, from a given point. And I'll put a blank space there. So the given point is called the center. And then that given distance, so to say that all these points that are on the circle are a given distance, the same distance, that's called the radius. Okay, so that's our geometrical definition of the circle. It has nothing to do with the equation x squared plus y squared equals r squared, or I guess it might, but the definition itself doesn't immediately tell you x squared plus y squared equals r squared is the equation. Number 3, an ellipse is a set of points such that the sum of the distances from a point on the ellipse to 2 fixed points called foci is constant. Okay, that is a far more complicated definition than the definition of a circle. So we've got these points here called F1 and F2. F1 and F2. The plural is foci, but that's the plural of a singular word, which looks a little bit different. A singular focus. So one focus, 2 foci. So here's the idea. It says that the sum of the distances from a point on the ellipse to 2 fixed points. So we're going to draw the distance between the one point on the ellipse A and the one focus F1. And then in another color, I'm going to draw from A to F2. So it says the sum of the distances, so the length of purple plus the length of red, is constant, regardless of where that point A is on the ellipse. So for example, if I look at point B, and I connect B to F1, and then B to F2, then that sum, green plus blue, is supposed to equal the sum on the other side. So for any point on the ellipse, we should have some equation that's quite colorful. If you take a look at the length of purple plus the length of red, it's going to be the same as the length of green plus the length of blue, and it's going to be the same no matter where you are on the ellipse. So for example, if I pick this point, let's say right over here, I get to walk very short that way, but then longer this way, and the sum of those 2 black lines is the same as the sum of purple and red is the same as the sum of green and blue. So that's the definition of an ellipse, and that's how we make an ellipse. And so down here at the bottom, it just says, I think what we said, for all points A and B, A to F1, the distance between A and F1 plus the distance between A and F2 is the same as the distance between B and F1 plus B and F2. 4, you've seen equations for parabolas before. They're called quadratic equations, but quadratics are just one way to analyze parabolas. Here's a purely geometric way. A parabola is a set of points such that each point is equidistant from a fixed point called the focus. We've seen that word before, and a fixed line called the directrix. We have not seen that word before. So here's the basic idea. You have this line right here, the directrix, that's given. You have this point right here, the focus, that's given. You have a, and that's all you have. And the idea here is that we're going to try to come up with a way to define all these points here on the parabola. So the idea is you pick a random point, call it A, you take a look at the distance between, let's use the same curved colors we used before. I think we had purple and red. So if we take a look at the distance between, at the distance between point A and the focus, and then in red we look at the distance between point A and the directrix. And when we say distance between a point and a line, we mean the shortest distance, the straight line perpendicular distance. So if you look at the lengths of purple and red, you should convince yourself that they look like they're pretty close to each other in length. And so we'll mark them as having about the same length or having exactly the same length with those little lines on each. So that's true for that point A. What if we go way out here to this point B? So again, we'll connect the point to the focus. So that's over to here. And then separately, we'll connect point B straight down to the directrix. And are blue and green equal to each other? Well, it kind of looks like it. So we'll put 2 hash marks. They're equal to each other. They're different from purple and red, but equal to each other. And the same thing is true even if you picked a point that's really close to the focus. That little tiny distance there is supposed to be the same as that little tiny distance there. And that's written up right here for all points A on the parabola. Distance between distance dA is equal to FA. I have no idea what dA means. I guess the distance between the directrix and A, and then the distance between the focus and A. So that's what it means, but this is kind of a strange way to write that. Now, of course, I wrote it, so I have nobody else to blame, but it's a little bit weird. Okay, so that's our geometric definition of the parabola. Next page is the least familiar curve to us at this moment. A hyperbola is a set of points such that the difference between the distances from each point on the hyperbola to each of 2 points called foci is constant. Okay, so here we have one focus and another focus, and then some constant which doesn't really appear, at least not in an obvious way in this picture. And we're going to pick a random point A on the hyperbola out here. And then we're going to draw from A to one focus and from A to this other focus. And then we're going to subtract them and we're going to get some magical number, and I don't know what that number is, but we're just going to say red minus purple because it says subtract them, the difference between the distances. Red minus purple. It's supposed to equal some constant. Okay, I don't know what that constant is, but let's pick another point on the hyperbola. We can pick it on either hyperbola. Let's pick one that's, let's pick a point that's really close to this focus here. And then we're going to do 2 different colors here. I'll connect to the one focus, and I'll connect to the other focus. And then we're going to subtract these guys, minus green. Equals. And the basic idea here is that if you're actually a point on the hyperbola, then these 2 differences should be exactly the same. I'll call them C for constant. They're equal to each other. You could write equals each other. Sure, this purple is a lot longer than this green, but the red is also a lot longer than the blue. And in fact, if you subtract red minus purple, you'll get exactly the same thing as blue minus green. That's what this thing says. Difference, that's our subtraction, between the distances, that's purple and red, blue and green, of any point on the hyperbola to each of the 2 foci is constant. For all points A, the difference between the length from A to F1 and the length from A to F2 is always the same. Absolute value is here just so we don't have to worry about making sure we subtract big minus small. Number 6. Today's activity is from that web page. In order to do this activity, you need 2 other people, a piece of sidewalk chalk, and about 10 feet of string. I cannot help you find 2 other people that will work with you on this, but you should know that the 2 other people do not need to be in your pre-calculus class. They can be 2 friends or 2 family members or 2 random people that you meet on the street. You just need 2 volunteers to help you with the string and chalk. So outside of my office, let's see, if you have chalk and string and 2 friends who are willing to work with you, then go outside and do the activity. But if you don't have chalk or string, you can come by my office. and picks them up. I'm going to leave them outside my office for a little while. And so just come by when you can. You're going to take 3 different colors of chalk, 1 piece of string, and you're going to work through the activity. And please return my chalk and string when you're finished. And so just one thing that I'll say about this human conics activity, again, groups of 3. I don't think you should tie the rope at any point, so try to avoid tying the rope. And one thing you definitely need to do is write down the answers. Don't just do number 1 and then do number 2 and not write anything down. You really want to have a record of your answers. Okay, in terms of checking your work, or what do you do if you get stuck, since you're not going to be doing this in front of me most likely. I was thinking about making a video for this activity, but I've decided not to do that because the materials at this website here are very, very detailed, and the materials at this website are written for the teacher. They're teacher materials, which means there's a complete answer key to the problems, and there are also hints that it says you can, as a teacher, share with your students. So I trust that you're not going to just go to this web page and fill in the blanks here. That would not do you much good at all, but give this a shot. If you get stuck at any point or you're just not sure whether or not you're doing the right thing, take a look at the website. Try not to read all of the answer. Just try to find some hint that's relevant to the part that you're working on. But like I said, at some point, if you just want to see answers, feel free and go there. There are lots of details at this website.